In this section, we are going to introduce another coordinate system. In mathematics, it's often an advantage for us to not work in our usual coordinate system, which is our rectangular coordinate system that we see here. We're working with points x and y. The movement in the rectangular coordinate system is always straight lines. We're moving on a grid, so we're going left, right, or up and down. So it's very limiting when it comes to functions that curve. So in this section, we're going to look at an alternate way to graph points using what we call the polar coordinates. And in polar coordinates, we're going to graph ordered pairs r and theta. R is going to be a distance out from the center. Theta is going to be an angle measurement. So we're going to go along in a circular motion. So this would work well with functions that are circular. And then let's go ahead and compare these two graphs. So in the rectangular coordinate system, we have the center, the point 0, 0, and that's called our origin. In polar coordinates, we have a center as well, and it's also 0, 0, but this is called the pole. Let's just go ahead and graph some points, say 4, 0, and compare in rectangular coordinates to that of polar coordinates. So here my x value is 4, my y value is 0. I'm going to graph that same point in our polar graph. So just imagine here, and I'm going to draw a cross, that this is like the x and the y axes. So you can actually take these polar coordinates and kind of impose them on the xy. So the point 4, 0, where it is in our rectangular coordinate system, will be actually in the same position in polar. But in polar, let me go ahead and graph this 1, 2, 3, 4. So this would be the point 4, 0. So it's the same distance away from the center. But instead, the way we describe it is by the distance out. So the distance out here is 1, 2, 3, 4 units. And the angle, well, we're on a radian of, if my angle's in radian measurements, we're on an angle of 0. So in polar form, this would be 4, 0. But again, this 4 is an r value. There's a distance out from the center. You could think of it as a radius. However, in polar coordinates, angles and r values are allowed to be both positive and negative. And then this 0 is going to be our angle theta. So in rectangular coordinates, there's only one way to represent a point, because we can't keep going around and around and around infinitely many times like we can in polar coordinates. So polar coordinates are similar to our unit circle. We can go, when we talk about an angle measure, we can keep going around and around as many rotations as we want and in any direction. So another way that we can describe this point is, imagine if I went all the way around and came back again to an angle of 2 pi. So I can also say this is 4 comma 2 pi. Or if I went in the negative direction, I could say this is 4 negative 2 pi. However, r can also be negative. So imagine if I were to go around to pi, and that's my angle. Well, if we do a negative r, then we would be back at that point 4, 0. So if r is positive, when you move, you're going to move towards your angle. So in the case where theta is 0 and r is 4, the movement is from the center to the point going towards your angle. in the case where r is negative, so if I'm at pi, if I'm looking at pi, I wouldn't go towards pi units, 4 units. I would go away from pi. So this is the idea. If you have negative 4 for r and say pi, then that means you're going to go to pi, but instead of going 4 units towards pi, you're going to go 4 units in the opposite direction. So you would actually be going the 4 units towards 0. Okay, so a negative r means you go in the opposite direction of your angle. A positive r means you're going in the same direction as your angle. And that's the confusing part of working with polar coordinates, is that there's infinitely many ways to describe the same point. An important thing for us to be able to do is to be able to go back and forth between rectangular coordinates and polar coordinates. And this would be our conversion. And it kind of follows with what we were talking about with the unit circle. So remember originally we said that x is going to be cosine and y is going to be sine, but that would be on the unit circle where the radius is 1. And then we kind of went to any circle and we said, okay, well, the x value is going to be r cosine theta, and the y value is going to be r sine theta. So we're still using those relationships. And then here, from the unit circle, we had x squared plus y squared is equal to 1. But then we said, okay, well, for any circle centered at the origin, x squared plus y squared is going to be equal to r squared. So in that way, we can go back and forth between x's and y's and r's. But we also have another relationship with respect to the angle. Tangent of theta, remember that's y over x. That still holds. We just don't want to have x equal to 0 or else it's undefined. But that's okay. If you know the tangent is undefined, then you can just look at the angle measures or the theta values that make tangent undefined, such as pi over 2. So first thing we want to do is we want to be able to practice plotting our polar coordinates. So remember, when we say polar coordinates, we're looking at an r value and a theta. In part A, I want to graph 1 comma 2 pi over 3. So here, the 1 is the r, and the 2 pi over 3, that's our theta. So what I usually do, even though the r comes first, instead of going around 1 and stopping at 2 pi over 3, which I could do, I actually go to 2 pi over 3 first. So here's our 2 pi over 3. And then I'm going to go a distance of 1. So a distance of 1 would give me this point here. And now since I'm looking at, and I don't really want to have this line here, because remember, polar coordinate, like a coordinate in rectangular form, is just a point. It's not that line. It doesn't, I just use the line to show where we're going. So that would be my point 1 comma 2 pi over 3. Now I could write that ordered pair on this coordinate system, but it's going to get kind of messy. So since this is part A, I'm just going to label this A. Now the next one, B, the R value is negative 4, and the theta is 2 pi over 3. So same angle, I'm going to go to 2 pi over 3, but instead of going 4 units towards 2 pi over 3, I'm going to go in the opposite direction, and I'm going to go 1, 2, 3, 4 units opposite direction. I'll end up here. This would be my point B, going towards 5 pi over 3 actually. Okay, so negative r means opposite direction from the angle. Now C is positive 4 for r and 5 pi over 3. So I'm going to go to 5 pi over 3, and if I go positive 4, so 1, 2, 3, 4 to 5 pi over 3, I'm actually at the same point as point B. So C and B are the same point. And then we can also use degrees instead of radians. In part D, it's the point 5, comma, negative 30 degrees. So 5 is our R. I have to figure out where negative 30 degrees is. Well, 30 degrees is pi over 6. So I'm looking at a negative pi over 6. I'm going to go in the opposite direction. So that would actually be the same as 11 pi over 6 if you're looking at the positive. So at 11 pi over 6, which is negative pi over 6, which is negative 30 degrees, I'm going to go out 5 units. Okay, so again, I'm going 1, 2, 3, 4, 5 out. But I don't want to keep that on there because you might think that the line is part of it. And that would be our D. In example 2, I'm going to find the rectangular coordinate for the given polar coordinate. Now, when you're going from polar to rectangular, when you're looking at points, it's very easy because remember that if this is polar that I'm working in, that this first number is an R and this is a theta, and I already know that x is equal to r cosine theta. So all I have to do is just substitute 5 for r and pi for theta. That's my x value. So it's going to be 5 times negative 1. X is going to be negative 5. And then my y value is going to be r sine of theta. So just plug in 5 for r, and then it's sine of pi. Sine of pi is just 0. So my y value is 0. And I wouldn't stop there because we're supposed to be finding the rectangular coordinate. And the coordinate is an x and a y value as an ordered pair. So this parentheses negative 5 comma 0, this is the final answer. That would be the rectangular coordinate. So you wouldn't just stop at x is equal to negative 5, y is equal to 0. Now let's look at B. Again, we have r, this is square root 2, and in this case, theta is negative pi over 6. So my x value is simply square root of 2. So r cosine of theta is negative pi over 6. X is going to be square root of 2. So cosine of negative pi over 6, that's in quadrant 4. Well, cosine of pi over 6 is what? Square root 3 over 2? So in quadrant 4 is still positive, going to be square root 3 over 2. So just look at your unit circle. And then that will give me an x value of the square root of 6 over positive 2. Our y value is going to be, square root of 2, sine of negative pi over 6, which is the square root of 2. Sine of negative pi over 6. So sine is negative in quadrants 3 and 4, but negative pi over 6 is in quadrant 4. That would be negative 1/2. So we have negative square root 2 over 2. And again, we're not done. We have to write the ordered pair. And the ordered pair would be the square root of 6 over 2 comma negative square root 2 over 2 in parentheses. So again, going from polar to rectangular, when you're just trying to find a point, super easy. You just do a straight substitution. Now, when you go from rectangular to polar, you always have to keep in mind what quadrant you're in. Okay. So this in example 3 says plot the rectangular coordinate and then find 2 pairs of polar coordinates where the theta value is between 0 degrees and 360 degrees. So in this case, I'm not working in radians, I'm working in degrees for theta. The rectangular coordinate that I was given is the point 0.04, so that's an x and a y. So remember, we're going rectangular to polar, and I have to find the polar coordinate. So I'm going to graph this, and it's going to be 0 for x, 4 for y. So I can look at that point and imagine that this is going to be 0 degrees, 90 degrees, 180, 270, and then when I come all the way back around, I'm at 360 degrees. So we're going in degrees, and imagine our theta starting at that positive x-axis like we've been doing this whole time when we were graphing circles, and we're going to go around. So if you did look at this point, 0, 4, the angle that it corresponds to is 90 degrees, and we're going a distance out of 1, 2, 3, 4. So I can see that 4, 90 degrees would work. And then if I look opposite of 90, I have 270. So if I go to 270, but I go in the opposite direction, a negative 4, then that will also get me to that same point. So I can see that an R value of 4 and a theta of 90 degrees, that would be one point. And the other would be negative 4, 270. But that's just because this point is on the y-axis. So points that are on the x or the y-axis in rectangular form are very easy to convert to polar. However, if you were not on the x or the y-axis, you might want to use those relationships. If I was going to find my angle, I would use the tangent of theta is going to be equal to the y value, in this case it was 4, over the x value, which is 0. And this is undefined. So I have to think, what theta values would make tangent undefined? So tangent is undefined at 90 degrees and at 270 degrees. So those are the two angles that will work. And here I was told that I'm only going to be choosing angles from 0 degrees to 360 degrees. So then what I would do is I would use the fact that the r squared is equal to x squared plus y squared. So I know that r squared is equal to x is 0, so that's just 0 plus y is 4, so that would be 16. Since r squared is equal to 16, I know that r is going to be equal to plus or minus the square root of 16. So r is equal to plus or minus 4. So all you have to do is look at the choices. When r is equal to 4, what theta goes with that? So first start at the 90 and say, oh, okay, if I'm at the center, I would have to go 1, 2, 3, 4 towards the 90 degrees. So it must be 4, 90 degrees. Well, what if I'm at r equal to negative 4? Okay, well, if I am at 90 degrees and I go negative 4, then I would go in the opposite direction. I would go oops, that's junk. I would go 1, 2, 3, 4 in the opposite direction. Oh, okay. Well, that's not going to work. I don't get to that point. So then you would go to the 270 and say, okay, if I'm at 270 and I go in the opposite direction of 270 units, will I get to 90 degrees? And the answer is yes. If you're at the center and instead of going 4 towards 270, you go 1, 2, 3, 4 in the opposite direction, you're at the correct point. So these would be 2 points, and sometimes you get more than 2 choices, but typically you get 2 choices. So these are the 2 points that in polar that will match with the 0, 4 in rectangular. In part B, again, I have an x and a y value. My x value is negative square root 2. My y value is positive square root of 2. Now I want to graph this, so it's kind of hard for me to graph without using a calculator because I got to estimate. And square root of 2 is about 1.4. So if I go to x value negative 1.4 and then a y value positive 1.4, I get a point about here. So that would be my negative square root of 2 positive square root of 2. Now you notice in this particular case, it's a little bit harder to guess what my angle would be and what my R would be. So in this case, I have to rely on those relationships. I'm going to use the tangent of theta is equal to the y value, which is square root of 2, over the x value negative square root of 2. So this is negative 1, and we have to think, when is tangent equal to negative 1? Well, tangent is negative in quadrants 2 and quadrants 4. And in that case, you could look on your unit circle, and that would be at 3 pi over 4. Or if you were looking in degrees, that would be 135 degrees. And then in quadrant 4, it would be 7 pi over 4 or 315 degrees. Again, just looking on the unit circle if you don't know. And what about my r values? Well, I know that r squared is going to be equal to the x squared. So negative square root of 2 squared plus y squared, which is square root of 2 squared. So r squared is going to be 2 plus 2, or 4, which means r is going to be plus or minus the square root of 4. R is equal to plus or minus 2. So we have two choices for my angles, and I have two choices for my r values. I have r is equal to positive 2, r is equal to a negative 2. So let's look at what happens if we go to theta equal to 135 degrees. Now I'm going to put a line all the way through here, and then another line that way. So this would be about 135 degrees, and this would be about 315 degrees. And they're opposite, which makes sense because I'm looking at a positive r and a negative r. So if I start at the center and I go out 2 units, and now it's not 2 units on the diagonal. Remember that the units here would be something like that. So if I go 2 units, I'm at my point, a positive 2 units, and that's if I do the 135 degrees. So the positive 2, 135, that would get me to that point, negative square root of 2, positive square root of 2. Now if I use the 315 as my angle, then my r would have to be negative 2. So if I go 2 units towards 315, that would be a positive r. So what I'm going to do is go to 315 and go in the opposite direction, and then I'll get to that same point, negative square root of 2, positive square root of 2. Okay, so now we're going to look at equations instead of points. If we're going from the rectangular equation with x's and y's to a polar equation, it's pretty straightforward because x is equal to r cosine theta and y is equal to r sine theta. So if you just substitute the x and the y, then you'll have an equation with r's and thetas. X and y's are gone. Now, sometimes Well, you can always do that, but sometimes it's easier to use r squared is equal to x squared plus y squared if it's applicable. So in this case, before I even change it to polar, I am going to, in yellow, lightly sketch x plus y equals to 5, thinking that I know what the graph is in rectangular. X plus y equal to 5. That's a line. So again, I'm going to kind of pretend like I have my x-axis here and my y-axis, and I'm kind of imposing this polar graph on a x and y coordinate system, the rectangular coordinate system. So what I would do is, if x is 0, y has to be 5. And I'm going to do this maybe in green, 1, 2, 3, 4, 5. And if y is 0, x is 1, 2, 3, 4, 5. So if I were graphing this in terms of x and y, I would have this line. So I'm going to switch this to polar and see if I get the same graph. Substituting, so remember x is equal to r cosine theta and y is equal to r sine theta. So in this equation, the x value would be r cosine of theta plus y is r sine of theta, and that's equal to 5. So my goal now, this is a polar equation, but my goal now is to get the r by itself equal to something. I notice on the left-hand side I can factor out the common r. So in parentheses, cosine of theta plus sine theta, and that's equal to 5. So if I just divide both sides of this equation by cosine of theta plus sine of theta, then on the left-hand side, the cosine theta plus sine theta cancels, and I get r is equal to 5 over cosine of theta plus sine of theta. And this is the equation in polar form, where you have the r by itself. And the reason why we want this r by itself is because that's how you would graph it if you're using a graphing calculator or an online graphing calculator such as Desmos. They usually require that you get the r by itself if you're going to graph a polar graph. So I'm just going to verify that I get this same line just by checking a couple points. I'm going to go ahead and make a table of values. I'm going to have an r and a theta. And let's just look at when theta is equal to 0 and see what our r value would be. So if I put in 0 for theta in this equation, this polar equation, I'm going to get cosine of 0 is 1, sine of 0 is 0. So this is 5 over 1, or 5. So in polar, I'm going to go to angle, a theta angle of 0, and I'm going to go 5 units towards. So yeah, so far that point's good. But what if I use pi over 2? Cosine of pi over 2 is 0, sine of pi over 2 is 1, so this becomes 5 over 1, or 5. So when I go to pi over 2, I have to go 5 towards pi over 2, same point, same graph. So remember what I said is when we go from xy to polar points, the point is in the same place on the graph. It just has we're just describing it in a different way. We're using different notation. So if I had a line in xy passing through those points, it's going to be a line in polar passing through the same 2 points. And again, you could put the r equal to 5 over cosine theta plus sine theta in a graphing utility and double check to make sure you get the same graph as x plus y is equal to 5. And you'll find it will be the same graph. Now let's do this again. And so notice, well, let me go back to this for just a second. Notice that the equation in rectangular is much simpler than the equation in polar. And that's because polar is not very efficient when it comes to graphing lines, but it's very efficient when it comes to graphing circles. Whereas rectangular, our xy is efficient at graphing lines, but when it comes to curves such as circles, the equation gets a little bit more complicated. So in B, we have x squared plus y squared is equal to 9. Rectangular, that's just a circle centered at the origin. The radius would be 3 because the 9 is the radius squared. So if I was looking at this in rectangular, I would see that I have a circle. Center is the point 0, 0. It's at the origin. And radius is 3. So I already know from the center, I'm going to go out 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, if I were doing this in X and Y. And also notice how nice it is to graph a circle when you're using polar coordinates, because the grid for polar coordinates is circular. So it's very nice. Let's see. If I'm going to switch this to polar, I could replace the x with cosine theta, r cosine theta, and the y with r sine theta. But notice that x squared plus y squared, that's r squared on the very first page when we're looking at those conversions. So I can replace the x squared plus y squared on the left-hand side with simply r squared, and that would be equal to 9. So solving for the r, this is r is equal to plus or minus the square root of 9. R is equal to plus or minus 3. That gives me two equations. I have r equal to 3, and I have r equal to negative 3. And they give me the same equation. So it doesn't matter which one you choose, I'm going to just choose the positive. So look how nice that equation is in polar, whereas in rectangular it's an x squared plus y squared equal to 9. So you got two variables. In polar, I just have r is equal to 3. I just have that one variable, and there's no square. It's very nice. So what this means is no matter what theta you choose, r is always equal to 3. So if I were to make a graph or make a table of values and say I had theta is equal to 0, maybe I'll do pi over 2, pi, 3 pi over 2. At 0, r is 3. At pi over 2, r is 3. Because that's what the equation says. It says, doesn't matter what your theta is, r is always 3. So if I go to my graph and I go to an angle of 0, I'm going out 3. If I go to pi over 2, I'm going out 3. If I go to pi, I'm going out 3. And if I go to 3 pi over 2, 3. And I get that circle. What if I had chosen r is equal to negative 3? And we'll go r theta again. 0, pi over 2, pi, maybe I'll just stop there. So negative 3 this time. Negative 3, negative 3. So if I go to 0, and I won't go 3 towards 0, I'm going to go negative 3. So I'm going to go in the opposite direction. I will be going towards pi. If I go to pi over 2, and instead of going 3 towards pi over 2, I'm going to the opposite direction, I'll be at 3 pi over 2. If I go to pi, and I go in the opposite direction, 3, I'm here. Now, let's see, 3 pi over 2, we'll do that one as well. Opposite direction, there's my point. Same graph. Doesn't matter if you choose positive 3 or negative 3. You're going to get the same graph. So the question is, what if you didn't see that you could replace the x squared plus y squared with the r squared? So I'm going to just quickly say, okay, well, we had x squared plus y squared is equal to 9. So if x is r oops, helps if I can write what I'm saying. If x is equal to r cosine of theta, and we're squaring it, so this would be x squared, plus y squared is r sine theta. If that's equal to 9, this is fine. You could have done it this way. If you distribute the square, it becomes r squared cosine squared theta plus r squared sine squared theta equal to 9. It's just more work. And then you see if I factor out that common r squared, then in parentheses I'll have cosine squared theta plus sine squared theta equal to 9. But cosine squared plus sine squared, that's just 1. So this is 1 times r squared, which would give me r squared is equal to 9. And then I'm back where I was before, where I'm squaring both sides, square root both sides, and I'll eventually get plus or minus 3. So it's not wrong, it's just a lot shorter to replace the x squared plus y squared with r squared. So in example 5, we're going to go from a polar equation to a rectangular equation. Usually when we go from polar equation to rectangular xy equations, it can be a little bit tricky. You might have to play around with the equation. So for example, in A, we have r equal to 4 times cosine of theta. Now, if I had an r squared instead of an r, I could replace it with an x squared plus y squared. Also, if I had r times cosine, I could replace that with an x. However, remember, this is simply an equation, r equal to 4 cosine of theta. And in any equation, I'm allowed to multiply both sides by some number. So why can't I simply multiply both sides by r? On the left, I'll have r squared. And on the right, I'm going to put the r after the 4. So I'm going to have 4 times r times cosine of theta. And then on the left-hand side, I can replace the r squared with x squared plus y squared. And I have a 4. The r cosine is x. So now I have an equation in rectangular. I got rid of all the r's and the thetas, and I only have x's and y's. Now I want to graph that. Since the x is squared and the y is squared, that tells me that it might be a circle. And typically when we graph circles, we want to bring all the x's together and all the y's together. So if I minus the 4x from both sides, then I could have the x squared minus 4x together, and then I would complete the square here on the x squared minus 4x. So remember how we complete the square. We take the negative 4, take half, and square it. So that's equal to negative 2 squared, or positive 4. So I'm going to add 4. But I have to add it to both sides so that I keep that equation balanced. What you do to one side, you do to the other. So x squared minus 4x plus 4 plus y squared, and then I have to add the 4 onto the other side as well. The x squared minus 4x plus 4, that factors to x. Remember, this was a minus 2 squared. So it's x minus 2 squared plus y squared equal to 4, which is a circle. It's a circle with a center at 2, 0, and a radius equal to 2. Because remember this 4, this is r squared. And when we talk about a radius, this is not the same as the r in polar coordinates. The r in polar coordinates can be negative or positive. But the r in a circle in our rectangular coordinate system with x's and y's is always positive. So we would choose, if r squared is equal to 4, we would choose r equal to 2 when we square root 4. And the center is whatever x value gives you 0, in this case if x is equal to 2, and whatever y value gives you 0 on the y squared, in this case it would be y equal to 0. So I have this circle, the center is going to be at 2, 0. And then the radius is 2, so I'm going to go out 2 from the center. And I'm going to sketch my graph. My sad graph. So this would be the graph, which I kind of didn't know what the graph would look like until I got it in a standard form for a circle. Now, if I look at the polar form, just looking at this, it's r equal to 4 cosine theta. Cosine is x value. Think about it as x value. And this circle is on the x-axis. If we go out 4 from the center, I have a point on my circle. So if this were graphing in polar, you could just put in different theta values and you would get the same points and you would get the same circle. Again, you could put those in Desmos to double check. So r equal to -5 cosecant of theta. Okay, well, I'm switching this to rectangular. I don't have a cosecant in there. I have a tangent. So my first instinct is I have tangent, I have sine, I have cosine, but I don't have cosecant. So my first instinct is to get rid of the cosecant and change it to the reciprocal of cosecant, which is sine. And then I'll kind of see what I have. So this is going to be r equal to -5 over sine of theta. Okay, again, cosecant reciprocal is sine. But now I can see what I need to do. I need to multiply both sides of this equation by sine of theta. So on the left, I'm going to have r times sine of theta. And on the right, the signs cancel, and I have -5. Okay, but what is r sine theta? That's y. So this is simply the line y equal to -5. So remember, if it's just a y value and there's no x, then the line is going to be a horizontal line. We just go down to -5, plot our point, and draw our line. So lines in xy are really nice. Look at that equation. It's just y equal to -5. But the equation in polar are a little bit more complicated. And that's it for this section.